Okay, so basically, this lesson is about working backwards. They're actually giving you the x-intercepts, and you work backwards to create the function. Okay, you work backwards to create the function. All right, so let's see. Hold on. Let's see if I can create a box here. Okay, whatever. As long as you can see this says multiplicity of 2, that's all I care about. Okay, which I think here, let me just be 100% sure and make that white. Okay, multiplicity of 2. Okay, so they're giving you the x-intercepts, we work backwards. Okay, so watch this. If the x-intercept is 3, then in factored form, it's x plus 3. Okay, and if they're giving you -2 as an x-intercept, in factored form, it is x minus 2. Excuse me, my bad. Plus 2, and I made a mistake over here. This should say, okay, this should say x minus 3. Okay, right over here. X minus 3. All right. And -1 multiplicity of 2, people trip out on this. This is actually a super easy concept. Multiplicity of 2 just means it occurs twice. So there's another -1. If it's at multiplicity of 3, then it would be another -1. Okay? All right. So I'm going to go x plus 1, x plus 1. All right. So look at these 3 highlights over here. 1, 2, 3. Boom, 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 boom. Okay, and multiplicity of 2. All right, that's pretty straightforward. Okay. Yes, that's correct. Okay. Now, watch this. I'm going to type in on Desmos. Okay. On Desmos, I'm going to type in what I just wrote. Okay. What the heck just happened over here? I said I want Desmos, man. Okay. And I'm going to go x plus 3. No, x minus 3. That's not x minus 3. X plus 2. Thank you. Let me fix that. Plus 2, x minus 1, x minus 1. Okay. Whoops. Boom. And okay. Now, if you look at Desmos right now, here are our x-intercepts. -2, 1, 1, 1. Hold on. I messed that up. Is 3, -2, -1. 3, -2, -1. This should be a plus. That should be a plus. Okay, there we go. So here's your x-intercept of 3. There's -2 and -1, -1. Because it's a multiplicity of 2, an even multiplicity, that means it bounces. Remember, even bounces, okay, and odds cut through. Okay, I could have also written it like this, okay, as a square, like that, and it'll be the same thing. Even exponent or multiplicity means it bounces. Okay, so now this is what we got over here. Okay, this is what we got over there. Now here's the thing. I'm going to throw in a coefficient here. Right now it's an invisible 1. I'm going to make it visible. Let's pretend it was a 3. If I have a second equation that has a 3 coefficient, look, I still get the same x-intercepts. Yeah, the blue graph is vertically stretched more, but I still get the same x-intercepts. Okay, I'm going to make this a 5. Okay, or heck, a 55. Okay, let's make it 5. I'm not going to get that crazy. Okay, it's vertically stretched, and you still get the same x-intercepts. Okay, I'm going to change this to a same thing. Let's do it. Okay. Check it out. Instead of stretching it, it compresses it vertically, and you still get the same x-intercepts. Okay. I'm going to make it a negative. A negative basically just inverts it. It rotates it, so to speak, or reflects it, I should say. That's the correct term. Okay, reflects it and stretches it because it's a 5. But it still has the same x-intercepts. So my question is, how do you know whether in front right here is supposed to be a 1, a 5, a 10, an 8, an 800? How do you know what it's supposed to be? Because this just asking for the x-intercepts, okay, just asking for the x-intercepts, I should put it this way, okay, whatever number we put over here satisfies this x-intercepts, okay? So we need to narrow down what number is over here, okay? We need to narrow down because right now we have an infinite number of numbers that we can put here. Infinite amount of numbers we can put here, yet still satisfy this. So what is the specific number that goes here? Okay, that is the key. That is what we're going to solve for. That is the only quote-unquote challenging part. So I'm going to put an A here, which is what we're going to solve for. And I'm going to put a P of X. Thank you for letting me know. Okay, so let me repeat what I just said. Okay, let me repeat what I just said. So whatever we put, okay, I just showed you on Desmos that whatever you put over here, whatever number you put over here, positive or negative, will satisfy this condition of x-intercepts. So the question is what number specifically goes over here? Okay, what number specifically goes over here for this specific polynomial? Okay, all right. So let's solve for that number. I'm going to call this A that we're going to solve for. All right. And I'm going to plug in this 0. Okay. I'm going to plug in that 0 right there in for the x. And the 12 is going to go right there. Okay. So as of right now, let's go ahead and solve it. Okay. I get 12 equals to A times -3, because 0 minus 3 is -3. 2, 1, 1. Okay. And I get 12 equals to A times -6. And I get -2 equals to A. All right. -2 equals to A. That is the hardest part. Okay. So as of right now, this is what I got. Okay. This is what I got as my polynomial. We're actually pretty much done realistically. Okay. This is what I got from, look at these green highlights. Okay. Look at these green highlights right over here. Green, 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 green. I'm going to overlap the yellow. Okay. And now that becomes this. Okay. Now we're done with the hard part. From here on out, it's just tedious stuff. It's just all tedious stuff. Okay. Now you just got to distribute all this out. Okay. You just got to distribute it all out. So I'm going to distribute. Watch this. Watch how I distribute this, because there's a method to the madness. Okay. Okay. Watch how I distribute it. I distribute the pinks right here. The top pinks become the bottom pinks. Ignore these red, green, blue strands right now. Okay, just notice that the top pinks become the bottom pinks, and the top orange becomes the bottom orange. Okay. And then I'm going to distribute, okay, and then I'm going to distribute the x squared through the red strands. Okay, the x squared gets distributed to the red strands. This negative x gets distributed through the green strands. the -6 gets distributed through the blue strands. Okay, so right now I'm going to write it. Let's see if I can do it fast. Okay, because this part's just tedious. And I get -2 parentheses. And let's go red, which is x to the power of 4, plus 3x squared. No, my bad, 2x cubed, plus x squared. The green is going to be -x cubed minus 2x squared minus x. Okay, let me just double check that. 2x squared minus x. And the blue is going to be minus 6x squared minus 12x minus 6. And then I'm going to close the parentheses. All right. I'm going to combine like terms. Boom, 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 boom. I'm missing one thing. This is a single underline, triple underline, triple underline. Let me just double check that. Okay, and you are going to get -2, x to the power of 4. The cubes become x cubed plus 1x cubed. The squareds become -7x squared. The cubes here, or excuse me, the x to the power 1s become -13x minus 6. Close the parentheses, and then finally you just distribute the -2. Done. Okay, done. So again, the only new part is just this right here on the left side. Everything else is just tedious. Okay, everything else is just tedious. I want you guys to go ahead and do this one problem here. By the way, as you finish up the previous 2 problems and this one problem here, I posted something. I don't know if you guys saw. Okay, I posted something on Google Classroom last night, and it looks like this. Okay, it was basically some word problems. Okay, because on your tests, whoops, let me stop.